Scalar has, as you know, it can be represented as one number. Vector, if you remember, this is represented by three numbers. And tensor, I don't think so you have much idea, but I'll explain it. This is represented by 9 numbers. Okay. Scalar has one unit. Of course, everything that we use in engineering has unit. Okay. Scalar has no direction. Vector has one direction. Tensor has two direction. Let us look at some examples. One of the example of scalar in heat transfer is temperature. We can also write temperature like this. I'll tell you why I'm writing like this. What is the example of vector? I can give you a second. Think about one. I hope you have thought, and I think you have thought of the vector. Velocity. This is how we represent a vector. I think we will go into this little more in the subsequent classes. Now comes tensor. One of the beautiful example of a tensor is the stress tensor. Equals to tau xx, tau xy, tau xz, tau yx, tau yy, tau yz, tau zx, tau zy, tau zz. Okay, this is called a stress tensor. And everything you can see can be represented by a matrix. The matrix could be 1 by 1 matrix. The matrix could be a 3 by 3 matrix. Okay. So a matrix is actually called a tensor. So in some books, if you go, the scalar is also called zeroth order tensor. The vector is also called first order tensor. The tensor is also called second order tensor. Okay, see, the 0 is coming from how many directions? This 1 is coming from how many directions? The 2 is coming from how many directions? You might be thinking now that there might be possibilities of third and fourth and fifth order tensor. Yes, there are, but we are not studying those. Those are scope of engineering. Maybe if you study physical chemistry, if you do higher studies on that, you might come up with second or the third or fourth order tensor. Viscosity is sometimes called a fourth order tensor. Okay, fine. Scalars, you have been using scalars since your childhood. Okay, this is just addition, subtraction, and everything. That's a P and Q are two scalars. Let me go back and clarify one more thing with you. See, here I have not used any symbol, anything, any prime, any bar, anything here. This is a scalar. So from now onwards, if I do not use any bar or any other notation with a letter, that means that's a scalar in any equation, of course. If I am putting a bar below, that means that is a vector. If I am putting two bars below, that means that is a tensor. Okay, remember that. You may follow that, or you may follow anything else which is there in the in any of the books. Okay, fine. Let's go back to scalars. Scalars you have been using very precisely since your childhood. If P and Q are two scalars, you can add P and Q provided the units of P and Q are of course same. You can also subtract Q from P. You can also multiply P and Q. You can do all kind of thing. You can divide P and Q. Okay. But when it comes to vector, things are not as straightforward as we have seen for scalars. Let's look at a vector. As I told you before, vector is written like this. How do you explain this? Let me take a moment and try to explain that to you. Let us consider a coordinate system, a Cartesian coordinate system, of course. Let's go with the simple one. Okay. In x direction, if you remember your algebra um, or any mathematics course or any basic courses, you have unit vectors. You need the unit vectors in each direction to explain the vector in a very proper manner. So if you look at ex we can also write like this. The dimension of ex, if you see, the component is 1 in x direction. In y and z directions, the components are 0. Similarly, ey equals to 0, 1, 0, and exactly the same way, ez is equal to 0, 0, 1. Now, whatever you know from before, v can be written as ex vx plus ey vy plus ez vz. If vx, vy, vz are the components, three components of vx, okay, in the x, y and z direction, if that is the case, we can write ex as 1, 0, 0 multiplied by vx plus 0, 1, 0 multiplied by v1 plus 0, 0, 1 multiplied by vz, which is also equals to vx, vy and vz. That's what I have written before. So if we want to write a vector, one of the beautiful way to write a vector is v is equal to summation of I equals to 1 to 3 ex vx. No, ei vi, right? Sorry. That would be ei vi. Look, whenever I'm writing ex, ey, ez, I should put it bar below because ex, ey, ez are vectors. Vx, vy, vz are components of vector, but they are scalars here, right? Fine. So this is one of the beautiful way to represent vectors. Okay. So I equals to 1 to 3. Let me write down, expand this here. This will be e1 v1 plus e2 v2 plus e3 v3. Right. So here 1, 2 and 3 would be x, y and z, r, theta and z, or r, theta and phi, or any other coordinate system that you are defining. See, just be careful that this is only applicable for orthogonal coordinate system. These are not applicable for non-orthogonal coordinate system. Orthogonal coordinate system means all the axes or all the directions of the coordinate systems are perpendicular to each other. Okay, fine. So now I will also, ask you to check what are the different types of how can you add or subtract or divide vectors with each other. I'm not going to go into that, but I need to explain to you about dot products and cross products. Okay, fine. So let's look into dot product. Let's say I have a vector A and that is represented like this. And I have another vector B and that is represented like this. Maybe J 1, 2, 3, EJ, EJ. Okay. So A dot B. What you know before? You know that dot product between two vectors will be A, the component of A multiplied by component of B, sorry, magnitude of A multiplied by magnitude of B multiplied by cos theta, where theta is the angle between A and B. Now when you do studies with heat transfer, like now you are studying advanced heat transfer. If it is a convective heat transfer, there will be so many vectors and there will be so many angles between vectors. So how can we define each and every angle and find dot product for each and every pair of vectors? That's not very much, good idea to find, right? So instead, there is another way where you don't have to worry about the angle between two vectors. Okay, that is, let us just take from the very simple way here. I am writing A dot B. Now I don't know what to do, so I'm simply writing summation of I equals to 1 to 3 EI AI dot summation j equals to 1 to 3 EJ BJ. I put a dot. Remember that the dot product is only applicable between two vectors. Let me write down what I am trying to say. Right, between two vectors. So in this case, what we can write here is equals summation I equals to 1 to 3 summation j equals to 1 to 3 AI, this is a scalar, bj, this is a scalar, multiplied by ei dot ej, right? Now I runs from 1 to 3, j runs from 1 to 3. That means this is xyz, this is xyz. So this is xyz, xyz. So there are so many possibilities of terms. So if you want to expand this, it will give, I think, to how many terms? 9 terms, I guess. Yeah, it will give you 9 terms. But are all the 9 terms we have, like, are existing, or some of them are going to 0? So for that, we need to go ahead and talk about this guy. ei dot bj. Okay, so for that, let me take you back to the dot product of unit vectors. That means you have, let's say, coordinate system. It really doesn't matter what you are writing. I like to write 1, 2, 3 because it makes things easy. You can write x, y, and z. Here you have ex, here you have ey, and here you have ez. Ex dot ey equal to 0, you know that. ex dot ex is equal to 1, we know that, and subsequently you can write for all others. Same way, if you define a coordinate system which are 1, 2, 3, 1, 2, and 3. For the one direction, the unit vector is E1. For two direction, the unit vector is E2. And for three direction, the unit vector is E3. Okay. So here we will have U1 dot E1 equals to 1. U1 dot E2 equals to 0. U1 dot E3 equals to 0. Now E2 dot E1 equals to 0. E2 dot E2 equals to 1, and E2 dot E3 equals to 0. Now E3 dot E1 equals to 0, E3 dot E2 equals to 0, and E3 dot E3 equals to 1. Here you can see that E1 dot E1, E1 dot E1, E2 dot E2, and E3 dot E3 are 1. E1 dot E2, E1 dot E3, E2 dot E1, E2 dot E3, E3 dot E1, and E3 dot E2 all are 0. So you can see a pattern here. That means if I want to find dot product between two vectors, this will be 0 if I is not is equal to j, and this will be 1 if I equals to j. So there is a very universal definition for this, which is called I dot ej equals to delta ij. This is called conical delta. Okay, and this conical delta that is there, which is if I is equal to j, delta ij is equal to 1, and if I is not is equal to j, delta ij is equal to 0. Right? Okay. So now using this, we can see what this will become, a dot b. So now a dot b equals to summation of I equals to 1 to 3, j equals to 1 to 3, ai bj delta ij. Or anyway, we will have 9 terms, and out of 9 terms, 6 term we will have delta ij where I will not be equals to j, and 3 terms will have delta ij where I will be equals to j. You can expand the summation and try to find out that as well. Okay. So finally, what we will do is we will remove the terms where the I is not equal to j, and that will give us I equals to 1 to 3, or I is equal to j ai bi. This is nothing but a dot b. If you know the components, all the components of two vectors, and if someone asks you to find out the dot product between two vectors, you can happily multiply the corresponding components and add. Okay, that will give you the dot product. Okay, this is a different way of representing dot product what you have learned before. So in the same way, you can also ask me what will be the cross product, right? Okay. So cross product, let's see. Let's just try to do it the same way, and let's see if you are getting anywhere for that. So let's say I need to find A cross B. for the same vectors as you have defined. I equals to 1, 2, 3, AI, EI cross J is equal to 1, 2, 3, or AI, EI, or I can simply write BJ, EJ. It doesn't matter how you are writing. Or summation of I equals to 1, 2, 3, AI, or we can simply write summation of J is equal to 1, 2, 3, AI, BJ, EI cross EJ. Look at here. This cross product only acts between vectors. Not took scalars. So I took the summations to one side, I took both the scalars to one side, and I took both the vectors to one side with the cross product with them. Okay, fine. So now same way, what will be this? For this, we need to go back and we have to find out cross product between unit vectors, the same way that we have done before. Okay, so here you know that E1 cross E1 will be 0. E1 cross E2 will give you E3, and E1 cross E3 is really weird to go through, will give you minus E2. Same way, E2 cross E1 will give you, think about it, what if this will be? Minus E3. Now, E2 cross E2 will be 0, and E2 cross E3 will be E1. Now, E3 cross E2 will be minus E1. I think so. So okay, let us write 1. Let us write 1 first, then we will go to E3 cross E1 equals to E2. Okay, E3 cross E2 equals to minus E1. And finally, E3 cross E3 equals to 0. Okay. So now the same way, what will be EI cross EJ? Okay. For this, we need to understand something, that sum of 3 of them are going to 0. Okay. 6 of them are giving us a vector. These 0 are also vectors. Those are called null vectors. Zeros are called null vectors. And these all others are giving us one type of unit vector. Right? So for this, let me not say anything and directly go into the answer, what it will be. EI cross EJ actually will be I equals to, not I, K. Let us name something else. K is equals to 1, 2, 3, K epsilon I J K. Looks very weird, na? I understand that. So let us try to see if it is making sense or not. Let's say I equals to 1 and J is equal to 1. What will be this? Okay. So for that, first I have to tell you is what is epsilon ijk. That is something may not be making sense to you. Like chronicle delta, epsilon ijk is a symbol used quite a lot in coding called permutation symbol. Okay, so epsilon ijk is equal to 0 if either of two indices are same. If I is equal to j or j is equal to k or k is equal to I. We will go back to this, don't worry. This is equal to 1 if the sequence of ijk that we have is in the clockwise direction 1 2 3 or 2 3 1 or 3 1 equals to -1 if the sequence of ijk is not in a clockwise direction 1 3 2 2 1 3 and 3 2 1. Now let's see if we can find ei cross ej or not. Let's say I equals to 1 and j is equal to 2. So ei cross ej says that summation of epsilon ijk ek. So ij here will be 1 to summation of k equals to 1 to 3 ek epsilon 1 to k. Now this is a summation. We have to open this summation and this will become E1 summation of 1 to 1 plus E2, not summation, sorry, epsilon of 1 to 2 plus E3 epsilon of 1 to 3. If you look at the definition of permutation symbol, if either of two indices are same, like here we have two indices are same, here two indices are same, this will be 0. And whenever it is in a clockwise direction, that will be 1. So finally E1 cross E2 equals to E3. In the same way, if you try to find out if I is equal to 2 and j is equal to 2, what will be ei cross ej. So for that you have to do is, you know that ei cross ej equals to k equals to 1 to 3 k epsilon ijk equals to k is equal to 1 to 3 ek epsilon 2 k. Anyway, this epsilon 2 will be 0. So finally E2 cross E2 equals to 0. Okay, so now you understood how this is working. Now this guy we have to substitute in this equation. So finally A cross B will be summation of I equals to 1 to 3, j equals to 1 to 3, ai bj ei cross ej. It was like that, and then if you substitute summation of k equals to 1 to 3 ek epsilon ijk, you will get I equals to 1 to 3, j equals to 1 to 3, k equals to 1 to 3, ai, sorry, I should not put a bar below because this is a scalar, ai bj epsilon I j k ek. You can see that finally this is giving you a vector. It could be a null vector, it could be any vector. This is giving you a vector. But if you remember the dot product, that was giving you a scalar. Here is the dot product. This is giving you a scalar. Anywhere you have the unit vector multiplied, that is a right? Okay. So that was dot product and cross product. I just wanted to discuss with you. If you expand the cross product further, this guy, if you expand further, you will get A cross B equals to E1, E2, E3, A1, A2, A3, B1, B2, B3. Okay, so try to do that. This is a determinant of. I hope you can do. Okay. Same way you can also find different multiple vector products. Let's say I have A equals to summation of L equals to 1 to 3 EL, AL and B equals to summation of M equals to 1 to 3 EM, AN and C equals to summation of N equals to 1 to 3 EN, AN. What will be A dot B cross C? First thing, it will give us a scalar tensor vector. You can see that B cross C is a vector. A cross A dot another vector will give you a scalar. So finally, this should give you a scalar. So try to find it. If you do it correctly, you will get something like this. I am writing it in summation. You can try to find this in summation and expand it. See what you are getting. L equals to 1 to 3. M equals to 1 to 3. And N equals to 1 to 3. AL, BN, CN, M, and L. Check this, try to do this if you can. Okay, so this is a very introductory class for vectors and scalars. Next class, I will maybe in next video, I will discuss about tensors and how we can relate tensors and vectors together. Okay, so that I will be discussing in one of the next video. By that time, go through this one.